Good day, everyone. I'm Ivan Claire Mendoza of BS ECE 3B, and now I will present my performance task number 11 in ECE 27. In today's video, we will discuss about T flip-flop. T means toggle. The defining characteristics of T flip-flop is that the output will change with respect to the input along with clock signal. It is a modified form of JK flip-flop. A T flip-flop is constructed by connecting the J and K inputs, creating a single input called T. We provide only a single input called toggle or trigger input to avoid an intermediate state occurrence. Now, this flip-flop works as a toggle switch. The next output state is changed with the complement of the present state output. Hence, why a T flip-flop is also known as a single input JK flip-flop. So as you can see, this is the logic symbol of a T flip-flop. Whenever the clock signal is low, the input is never going to affect the output state. The clock has to be high for the inputs to get active. Thus, T flip-flop is controlled by stable latch where the clock signal is the control signal. Thus, the output has two stable states based on the inputs which has been discussed below. So here are the parts of the T flip-flop. The toggle input, clock, output which is the Q, inverted input which is the Q bar. Let's proceed to the excitation table. If the toggle input is equals to 0, the next output is equal to the present output. If the toggle input is equals to 1, the next output is the complement of the present output. So the complement of 0 is 1. And again, if the toggle input is equals to 0, the next output is equal to the present output. So the present output is 1. It is equal to the next output, which is 1 also. And if the toggle is equal to 1, again, the next output is the complement of the present output. So the present output here is 1. Its complement is 0, which is the next output. Using this characteristic equation, this proves that the excitation table is true. So, if T is 0, the next output, which is Q sub n plus 1, is equal to the present output Q sub n. And if T is equals to 1, the next output is equal to the complement of the present output, which is Q sub n bar. This is the basic logic circuit of a T flip-flop using NAND gates. And I have here the master-slave configuration of a T flip-flop by cascading another bistable circuit. Now, we will try to simulate the T flip-flop using EWB based on master-slave flip-flop with two asynchronous active low inputs. The preset makes the output high and the CLR makes the inverted output high. Now, let's turn the preset and CLR to high, and as you can see, the outputs are toggling because the T flip-flop is not initialized. Now, we will initialize the flip-flop by making the output high, for example, the preset. Now that the output is high, we will toggle the output. T flip-flop will be initialized by turning on the toggle and make the clock false signal. Then, turn off the preset. As you notice, we toggle the output and the T flip-flop is initialized. Let's demonstrate the function of the T flip-flop. First, the toggle input should be low. And as you can see, there is no change in the output. Since this is based on master-slave configuration, the T flip-flop is a negative edge triggering flip-flop. If the clock goes low, the T flip-flop operates and there is no change. If the toggle is high, every time the clock becomes low, the output toggles. So, now that the clock is low, the output toggles. Whether the clock turn high or low, the output toggles. So that is how the T flip-flop works in EWB simulation. That would be all, and thank you.